Good morning. How we doing?
Good morning, Ian.
You okay?
Good.
Fantastic. So this morning, Abdul's going to have to leave at about 10:40, 10:45, something like that.
Yeah.
Basically be double booked, essentially. So he's got other engagements that's now crossed over. So it's going to be a shorter session today. But yeah, over to you, Abdul.
Yeah, I'm fine. Okay. Welcome again, everyone.
Well, it's only checkers at the minute.
It's only me at the moment.
Oh, you're welcome.
Thank
Do
you,
you want to
Abdul.
wait? Do you want to wait
Yeah.
a few minutes, Abdul?
Yeah,
Okay.
we can still wait. Can still wait.
Okay.
Yeah.
Let me just message the group. Alex was there. Yeah, we'll give it another couple of minutes, and then it's going to be a one-on-one. You're going to have Abdul all to yourself today for about 40 minutes. Okay, I think we should just go ahead. 5 past. So
Someone is coming in.
yeah. Hey, good morning, Taewo. How are you? There's only a few of us, a couple of you today at the moment, and Abdul's got to leave at around 10:40, 10:45. So it's going to be a shorter session today anyway. But so if you want to get started with the session, Abdul.
Okay. Once again, you're welcome. Today's class is going to be very first one. Today we're going to be talking about transformation, data transformation. So talking about data transformation, earlier we have discussed data wrangling, and one of the things that we make our data wrangling to be complete is to do some data transformation and data engineering. When we talk about data engineering, of course, it depends on the kind of data we have that determines whether we are going to do data engineering or not. For example, there was a column in the data we were using that we call body mass index, BMI. Now, normally, the way BMI was gotten is you have the height of an individual, the weight of an individual, assuming that the BMI was not given to us, and we have the weight, we have a column for the weight, we have the column for the height in meter, the weight in kilogram. It is important that we can combine these two columns to become one. So instead of having the two columns separately, like the weight as a column and the height as a column, we can combine the two to form what is called body mass index. In this case, you have to know the formula. So by the time you apply the formula, you create another column that will just simply be body mass index. Let me cite another example. For example, we are dealing with the volume of a room. We want to get an accommodation, and in that accommodation, maybe what we are building, we want to check, calculate for price of an accommodation in UK here. And what have been given to us were the length, the dimension of the room, the length, the width, and the height of the room. So now it means we already have 3 columns for this particular data. We can just work with a column by combining all these three columns together in the form of a volume of the room, like length times breadth times height. So those are the things sometimes that we have to do. To reduce the number of entries we have in our data, or the number of columns we have in our data. Imagine we have 3 columns, and we have been able to combine the 3 columns to form 1. So such are data engineering, depending on the nature of the data we have. Unfortunately, we already have body mass index, and not the weight and height. Assuming we have the weight and height, we could have converted the weight and height to body mass index using the appropriate formula. That is future engineering. There are other things we can still do after during data wrangling, something like scaling or maybe billing. We want to bin some of our column to a particular range. We still want to use the BMI column, for example. In the BMI column, which is a numerical column, you have values that range from, let's just say, like 12 to like 80 in our data. We have some people with a body mass index of 18, 15, 20, 25, 30. But these unique values, they are somehow numerous. We want to make it to become categorical, like let's make some data between this range to this range to become something like underweight. And between this range to this range, let's make it normal. And between this range to this range, let's make it overweight. Let me cite another example that we can easily understand. For example, we have to measure the temperature of about 1,000 people. The temperature of about 1,000 people. And during the measurement of the body temperature, we got something like 25 degrees centigrade. We have 26 degrees centigrade. Some people 27 degrees centigrade. Some people 28 degrees centigrade, 29 degrees centigrade, and in some cases, we have 40 degrees centigrade. If we have this, we might just want to classify, because we have about 1,000 data we want to deal with. We can just let's just categorize this data into maybe high body temperature, low body temperature, and a normal body temperature. So we can just say moderate, normal, depending on how you want to code this. These are things we can also do with our data. For example, again, we have some people we have to give the income of like 10,000 people in the UK. 10,000 people in the UK. We have to, everybody, we were given a questionnaire where we just have to input our income per year. And for some people, we say 18,000 pounds per year, 20,000, 24, 28, 26, and we are talking about 10,000 data here. 10,000 data. So if we check the unique values of this data, it's going to be numerous. We can have as up to like 50 unique values. Some people will say 24,500 pounds. Some people will say 26,000 pounds. Some people will say 26,500 pounds. Some people will say 27 pounds, like that. But now, instead of having this lot of range, we could have just looked into low income, moderate income, and high income. We can just bring it into 3 categories: low, high, and moderate. So in our visualization, that is going to be easy. We're just going to have 3 unique values here. We can easily say that, okay, the number of unique values are moderate, low, and high income instead of the series of the income that individual has listed. This make it easier for us to give a good report. It's going to be easy to see that, majority of the people living in the UK has a low income. And we have to define what we call our low income. Maybe we say less than 25 pounds and less is going to be considered as low income. Maybe between 20 or less than 28 is going to be considered as low income. Between 28 to like 42 is going to be considered as moderate income. And between 42 and above is going to be considered as an high income. So that is going to be easier for us. It's going to be easily, if I want to present this kind of data, I can easily come and say, okay, this is the graph, this is the bar chart of what I have. And from there, you can see 3 distinct unique values. And from there, you'll be able to know that majority of the people living in the UK have low income. If we define our low income to be 28 downward. And between
sorry, Abdul, sorry to cut you short. I have a question.
Okay.
The conversion of room dimension to volume and the binning, is it data engineering?
Yes.
Okay.
It's data engineering, yes. Anytime you combine 1 or 2 data together to become one, becomes the data engineering.
All right, thank you.
Yeah, thank you. So now, if you do all this, it's going to make our visualization and your storytelling to be superb. Instead of saying we have this number of people, their income is is 20,000, and this set of people, their income is 21,000. This set of people, their income is 22,000. This set of people, like that. You can imagine the number of values we are going to have to explain if we don't bend it to like 3 categories. But by the time you bend it to 3 categories, our data and our storytelling is going to be very great. So such are what we are quickly going to look into. There are various methods of, okay, let me quickly share my Google Colab so that I can use that one to explain so that we understand better. It's our data, the type of data we have that determines what we're gonna do. But the Google Colab I want to share now, it is assumed that the data we are using has been cleaned. You cannot do any other thing except you first clean your data. You remove all the non-value, you replace them, you remove the you convert whatsoever you are supposed to convert. You do unique your values, your unique values. You ensure that they are properly labeled and so many other things. You should have done all those before you can go ahead to do the binning and do any data engineering. Or else, at the point when you are trying to multiply, in some cases, it's going to flag an error. Perhaps you cannot multiply a non-value with another value. You cannot multiply a string value with another value. So it's going to flag an error. So it's going to be assumed that all the data cleaning has been done. So let me quickly share this with us. Yes. Can you see? Can you see my Google?
Yes, we can see.
Yeah. Yeah. Good. It's still the same data that we were using before. That you can just continue from where we stopped, but this is what we want to do. We want to do data transformation. We want to transform our data. You already have the data. You have to transform it after cleaning them. Of course, as usual, we have to import the necessary libraries. So what I'm using here is simply this data, the item disease B that we were using before. That was the same thing I was still using. And now I have I just want to check the data. Of course, this one, I just pick it afresh. I didn't bother to do anything on it. Of course, you already know all what to do. These are all the columns we have in this data. You already know how to clean this data and whatever you are supposed to do. So I don't want to check anything like the info, nothing. It is assumed that we all know all those. Now, all I just want, what I'm interested in this column, body mass index. The body mass index at 16.60, 20.30, 26 point, and like that. And we have as many as, how many data entry do we have here? I can check. You can just check the f.shape. We have about 319,000 data here, rows here, and 18 columns. In this 319, if we are to check the unique value of the body mass index, we can never, let's try and see if we can check the unique value of the body mass index. Let me check. The f dot bmi dot unique. Okay, look at the unique value we have here. We have 16.6. This, you can see it's very numerous. You can see this does, telling us that we have lots of them. Imagine we want to explain this, it becomes difficult. You understand? It becomes difficult. Imagine we want to plot this. It's just going to be the kind of graph we are going to get. It's going to be a lot. So there will be no way for us to be able to distinctly explain this BMI. But if we want to explain, make sure we get it explained better, what we can do is to bin it. We can bin it such that we're going to assume that we want to bin it to like 3 categories. We can bin it to 4 categories, like on the way. And if somebody is less than 18 body mass index, is going to be said to be on the way. If it's between 18 to 25, it's going to be said to be normal. Between 25 to 30 is going to be said to be overweight, and above 30 is going to be said to be obese. So in this case, if we do it that way and we check our unique value, it's only going to give us 4. Like we are only going to have underweight, normal, overweight, and obese. You can see that that is going to be easily explained compared to this kind of continuous numbers we have here. This is the reason for binning. Now, if we want to bin this, of course, what we can bin, there are things like numerical data. If there are numerical data that are spread over a range of values, we can just bin them. There are different ways of doing this binning. We can bin such that if we know the boundaries, we just list the boundaries for our binning. Say, assuming the lowest one is starting from 12, okay? We now say, or we just say anything that is less than or from 0 to 18. Of course, we know the boundaries already. Or we say anything that is less than 18. Between 18 to that, to 24. And between 24 to 30, between 30 and above. That is, even if you are 100, if you are 1,000, which is not possible, or those are going to be outliers, we just say anything 30 and above is going to be that. So we already know the boundary. There are some cases where we are not dealing with any boundary. We only want to group it into three equal parts. For example, we have something that runs from 20 to 60. And we want to divide it into three equal parts. We can just say, divide this thing into three equal parts for me. If we say from 20 to 30, from 30 to 40, from 40 to 50. Okay, let's say we have 50. And the minimum is 20, while the maximum is 50. If you want to bin it into three equal parts, it's just going to say from 20 to 30, from 30 to 40, from 40 to 50. That is when we want to bin it into three equal parts. We can still bin it into three, but they are not going to be three equal parts. We can say 20 to 35, 35 to 40, and 40 to 50. You see, this one is not three equal parts. So this stuff have different ways when we want to bin it into equal parts, or when we have our own method of binning. Now, the first approach now, I want to deal with we have our own method of binning. And what we are interested in is the body mass index. If I have a body mass index and I want to bin, I want to say, okay, if we want to divide it into like 4 equal parts, in 4 different parts, not equal this time around: underweight, normal, overweight, and obese. Now, this is what's going to determine the number of bins we are going to have. I already have the labels 1, 2, 3, 4. That is underweight, normal, overweight, and obese. In that case, if it is 4, it means I'm going to divide it into 5 equal parts. If you check our fingers, you'll discover that we have 5 fingers, and of course, we only have 4 bends in between them. So that is exactly what this is doing. If we want to divide it into 3 bins, we are going to have 4. So that it's going to be 4 bins. If we need just only 2 bins, we are going to have 3. So that it's only going to be 2 bins. So the number of bins is going to be 1 more than the number of labels. Now, in this case, the bins I want to use between 0 to 18, 18 to 25, 25 to 30, and 30 and above. Why this one says float infinity? Because we don't know where the above starts. I hope you understand. We don't know where the above starts. Okay, let me quickly create another stuff here. Let me bring something here and explain better. Let me just copy the bin. If, for example, I don't know where I don't even know whether it's starting from 0 or not. I don't know where it's starting from. I might just say the minimum. I might just say, okay, get me the body mass index minimum. That is the head dot BMI dot minimum values. It's going to get the minimum, which I think is 12 this time around. I'm not sure. And of course, instead of saying to infinity, I could have just said, BF dot BMI dot maximum mass. This is going to get the maximum. The minimum is wrong here, the minimum. So this is going to, I hope you get that now.
BMI, you wrote BIM.
Hello?
Yeah, I said BMI, you wrote BIM.
Okay, oh yeah, thank you. BMI. Okay, so this one will take the minimum, while this one will take the maximum value. So if the minimum is 12, it's just going to use 12 to 18, 18 to 25, 25 to 30, and of course, if I like, I could have just used infinity from minus infinity here. That is anything that is less than 18. So there are different techniques we can use when we are not sure of where it's starting from. But of course, there is no BMI that will be 0. So let's just say from 0 to 18. That is why I've adopted this. And if I like, I can just end this at 100, or depending on the data I have. But I don't want to end it. I say to infinity, anywhere it stops. classify it as obeys. I can give another one and say, okay, stop at 60. If I stop at 60 and now put again that from 60 and above says invalid, I can bring it as invalid. So there are different ways, there are different things we can do here. Let me just comment this out. Okay. So now, if I run this, what this will do is that it will take the space between 0 to 18 and name it underway. Between 18 to 25 and name it normal. Between 25 to 30 and name it overweight. And 30 and above to infinity and name it obey. So if I run it now, it's going to run and then it's going to create a bin for it. Now I say, okay, since you have created a bin, create another column that is not in our data frame before and call it BMI categories. So, and this is how to, it's just going to take the BMI, cut it, and use the bin. Of course, we have defined what the bin is, bin and labels. So, and use the bin and label to give another value for them. So, if I run this, just copy your code. The only thing you just have to do is to call it any name you like. Any name, the new categories you want to form. So if I now run the head of our data frame, it's now going to contain another thing that was not there before, BMI categories. You know, this is BMI. It's not going to be beside the BMI. It's going to be at the end. So if I go to the end, and of course, this is what we have, BMI categories. You can see. The BMI categories have been to underway. Okay, let me bring them together so that we can see it better. Let me just curate. Let me just bring it beside. Of course, you still remember how to rearrange our column, the f column. Let me just do the column and rearrange. I believe you still remember this method, this quick method of rearranging our column. If I do it like this, I copy, I come back again, I say df.columns is equals to, I just copy the whole thing, df into whatsoever I have in the column. I'm not sure if I copy, okay. Now, I want the BMI categories to come beside the BMI so that we can see it properly. I will just copy it and delete it from here, place it beside BMI so that we can see it very well. Okay, if I rerun it now, it means BMI and BMI categories, they are going to be together. So, oh, what happened? Did I copy anything wrong?
After BMI category.
Yeah.
Okay.
I put comma.
Yeah, you put comma, yeah.
This is the problem now. I don't know. If you copy, let me put it again. Okay. Let me put double this and say what the problem is. That is not the problem. Then what could have been the problem? The column is equals to this, and I can't be copying, I can't be doing it one after the other. If you copy, the copy could have copied the raised values as 18 column now, values have this column, but the columns are complete. Let me copy it again. Maybe it's not properly copied. Oh, that is the problem when you copy. Okay, I think it should be properly copied now. Let me paste it again. Let me now rearrange. Oh. Let me now bring it here. Oh. Comma. Of course, it's copied. What is the problem? Of course, we have been using this method. Okay. Since I can't find that, okay, the have rather. And the f.columns, yeah, it's correct. I don't know what the problem is. Please go and try it. We have tried this one several times and we have been using it before. So don't let us. The above exception was the direct cause of the following, okay? Key. Oh. Everything has comma. And everything was correct. So I don't know. Please go and try it when you, anyway, all I just want to do was to bring the two together. I don't know why it's not, we are not getting it that way, but I can still do some other thing. Let's just try to see the two of them, the F into, let's bring the two together. Let's just look only into these two. If the two don't want to go, let's just look into the two categories alone. And then BMI.
You don't put it in string, BMI category.
Okay, yeah, thank you. Okay, since we cannot, I don't know what's happened, so you can try that. So this is what we are trying. We say anything that is less than 18 should be underway. We just want to visualize. You can see 18.60 is underway. 20, of course, is more than 18 is going to be normal. And we say anything above 25 should be overweight. No, yeah, overweight, right? To be overweight, you can say. And if we have anything that is above, okay, 30 is going to be obese, you can say. So we now have these three. If you check for the unique now, we check for the health dot BMI dot unique.
BMI category dot unique.
Yeah, oh, thank you, the F. Okay. If you check for this now, we are only going to have 4 distinct values.
Oh, BMI category is not
okay,
BMI.
thank you. I don't know the spelling. Let me go back and copy it. Thank you. Yeah, this shows that you are really following, and I'm happy for that. Yeah, BMI categories. You can see we have just only 4 categories. That is, oh, we still have another one, NA, right? Of course, I told you that we are to treat all the NA values, right?
Yes.
Yeah, so I assume that this data has been cleaned. You understand? So, but for this one I'm using, it's not a clean value. That is why you are still having NA. So, but we assume that it has been treated. This is better now. We only have underweight, normal, overweight, and obese. And after you have gotten BMI category, it means you may not even need BMI. You may not need BMI again in anything you want to do. If you like, you can delete it from whatsoever we want to. By the time you want to log it into machine learning algorithm, you can just remove this, remove the BMI, since you already have BMI categories. So that is how to do this. Another thing we can do is this time around, we don't, the former one was because we have what do you call it? We have a boundary for ourselves, which we classify as upper boundary, which we classify as 0, 18, 25, 30, and above 30. There are cases where you don't have any boundaries. You just want it to divide it into equal parts. I hope you understand.
Yes.
It is not every data. Like this one is going to be wrong. You don't divide it into equal parts. It's going to be wrong. Well, because we just want to use it to just want to cite it as an example. The things you can give into equal parts is, for example, you are to get the age of respondents, and then your age you are to bin it into like 18 to 20 to 25, 25 to 30, 30 to 4. You know, there are five equal intervals. Those ones, we have to group them into 5 equal intervals or things like that. It depends on how there is a way they used to set question, like, okay, from age 0 to 100, divide it into 10 bins. It means you are just going to divide it into 10 bins. It means the number of bins is going to be the number of your, what you have at the upper limit, you have 11. After you divide your lower limit, you define the upper limit. Then instead of 10, you now have 11, which shows that it's going to get 10 distinct bins. So that is what we want to do now. For example, assuming we don't have anything like we don't know what the boundaries are. We just want it to give the boundaries on its own. And we say, okay, get the minimum value. This is the F BMI dot minimum. Then get the maximum value. the maximum, then divide it into 4 equal parts. You can see we say 5, but it means 4 equal bins, labels. I hope you understand now. Because it's 5, you're going to get 4. But if it is 6, it's going to get 5. So divide it into equal parts and name them underway, normal, overway, and obeys. Once again, this is wrong because these are arranged that are standard. We cannot just divide into equal parts. So, but for demonstration purpose, we are using these techniques. So divide it into 4 equal parts. And when you divide it into 4 equal parts, name it this way: underway, normal, overway, and obey. Or if you like to say, name it part 1, part 2, part 3, part 4. Maybe we should just do that, since this is not a standard. Okay. Part 1.
I've got a question. So when do we use NumPy and when do we use pandas?
Okay. I'm coming. Part 1, part 2, and part 3, for example. When we use NumPy, for example, if you want to convert anything into, for example, you want to log in something like a number, you can generate a number through NumPy or maybe a NumPy array. You can see anytime we use something like NP is a NumPy. For example, we want to convert a particular number, maybe something like NA. You can say .NAN. For example, we want to convert this NAN into something else, or we want to input a number in an array and we want to call it NAN, we can use NumPy. NumPy is used to manipulate numbers to become a list, for example, majorly. Okay, let's just try to say majorly. If you have something that looks like a list, you use NumPy. If you have something that looks like a data frame, you use pandas. I think that sounds better.
Yes, that's better.
Yes. So you can see that pandas is built on data frame is built upon the series. When you have
excuse me, Abdul, sorry to cut you short. Like if we want to extract the numerical values of a column in a data frame, we can use NumPy. Yeah.
Yeah, because if you're using NumPy, it has become a list.
Not data frame again.
It's no more going to be a data frame. It's become a list. I hope we still remember a list.
Yeah.
And we can differentiate between a list and data frame.
Yeah.
Yes. So once you use a NumPy, it automatically gives you a list. Do you understand? And immediately you are using Panda, it becomes a data frame. It becomes something like a table. But if you just want it like a list, majorly you use a NumPy.
Okay.
There are some operations. If you want to do operation in a data frame, you have to make them to become a list and quickly do the operation and later take them back to the data frame. Then in that case, you use NumPy. I hope you understand now.
Yes.
For example, in one of my column, like the BMI column, if I want to use the BMI column, I want to do some manipulation with them, I can easily turn the BMI columns to a list. When I do the manipulations in the list, of course, most of the things I will be doing in the list is going to be using NP array, right? After I'm done with whatsoever, maybe I want to multiply everything by 2, I want to multiply everything by sine 20 or something like that. After I'm done, I can now go back and convert it back to pandas. You are going to do such things in building models where you will have to manipulate some stuff and take them back to the data frame. So that's just it. You use NumPy majorly in list, and you use pandas majorly in data frame. So, and of course, by the time you are used to all these, you do some projects, you will automatically understand most of these things. You will be used to them. So you know when to use them appropriately. Anyway, let's go back. We say let's divide them into 4 equal parts and call them part 1, part 2, part 3, part 3 rather, because it's 4 equal, okay, part 3, part 4, 4 equal parts. So, which is wrong for this kind of data. But if I run it, I can run it, and I want to call it BMI categories, and I run it. So if I go to the head, you will see it's going to create another BM categories, but this time around, their names are going to be part 1, part 2, part 3, part 4. So if I quickly rush through, you can see BM categories 2 is created. We have BM categories, we have BM categories 2. This one, BM categories have become part 1, part 2, part 3. It has divided them into 2 equal parts. Majorly, most of these will fall on part 2. Normal and underway, it means they majorly fall under part 1. So, which you can see that is not a good one. So it has divided them into, it's not a good one. So it has divided them into different equal parts. So that is on that. We still have, that is how to bend. You can as well go and bend your, which other one? You can as well go and bend this one, sleeping time. If the sleeping time is numerical, you can bend them. I don't know what you can bend them to be. Maybe anyone that sleeps less than 4 hours, maybe you should say insomnia or something like that. Anyone that sleeps between this and this, maybe you say normal sleeping. Anyone that is above maybe 8 hours, you say abnormal sleeping. You can as well go and adopt that for this sleeping time. So after the class, you can try that out. That is how to bend. Now we want to quickly talk about encoding. And talking about encoding, we have what is called we can use mapping. We can use encoding, and we can use get dummy. We can use label encoding. What do I mean by encoding? If you check some of our data, the data we have used previously, if you go and check under the cells categories, you will see that some of the gender, instead of saying male and female, they are putting 1, 0, 1, 0, 1, 0. In some of the data we have used before. Those kind of thugs are referred to as an encoding. It has been encoded so that anywhere you see 1, maybe is female. Anywhere you see 0, maybe is male. The reason is because some of the machine learning really don't like to work with categorical data. They love to work with numerical data. So you just have to look for a way of converting all your numerical data, all your categorical data to numerical data. Like under stroke now, I could have come and say, okay, anywhere that is no, say 0. Anywhere that you say 1, it means yes. You understand? So those are the things we do when we say we want to encode. And there are different methods of doing this encoding. The one I love most is using mapping. You use map to encode, you use one-hot encoding, you use get domain, you use label encoding. There are other different types of encoding. The one I love to use mostly is mapping. The reason why I adopt mapping is because you are able to define what you actually mean. You see, here I want to use mapping. Of course, before you use some of them, you have to import some other libraries. For example, if I want to use one-hot encoding and I want to use get domain, I want to use label encoding, you have to import a libraries from scikit-learn processing. You import this library. You can import label encoding, you can import one-hot encoding. It is not compulsory. Of course, you just have to use one of them. So if it is a mapping you want to be using, it's okay. If it is one-hot encoding you want to be using, it's good. If it is just on label encoding, just use one of them. You don't have to be using everything. So majorly, I use mapping a lot. So now, if you want to use mapping, this is all what you just have to do. The new thing I want to map it and call it gender map. I only want to map the mapping and the gender. Now, in my gender, in my cells, I have male and female. Of course, capital L, you have to understand how it was spelled, okay? If it is capital F and capital M, you put it like that. Anywhere you see male capital M, you put it as 0. Anywhere you see female capital F, you put it as 1. You have to check properly. If you go back and check, under your, you can see it's capital. So you can just copy it, so that you don't, of course, again, it has been assumed that you have checked everything and you have corrected everything to be female and male. So now, after that, you say, okay, in gender map, you are the one that gives this name yourself. Okay, you map it by saying male, I want to call male 0, and female, I want to call them 1. Anyhow, if you like, you can call me 1 and call female 0. And then this gender map, you now have to, maybe this is the way you want it to be on your data frame. Call it gender map. Then where are you mapping it from? You are mapping it from the cells, and then map it to this gender map you have curated here. Okay, this is what I use here. Okay, you can call it anything. Now, after you have run that, if you go and check your data frame should now contain something that is called gender map, and you only be seeing 0 and 1 instead of male and female. So if you scroll, it's going to be at the end. You check, you see gender map. And the gender map, we have 1, 1, 0. Anywhere you see 1 is female, anywhere you see 0 is male. And of course, if you go and check, you're definitely going to see that 0, 0, male, 0, 0, like that. So that is how to use mapping. Apart from using mapping, you can use one-hot encoding. This is one-hot encoding. So using get domain. So if you are using your get domain to get your one-hot encoding, you just have to go back to your data frame, and define what you want to, just put whatsoever you want to use one-hot encoding on. I want to use it on self. If I don't want to use it, I can use it on asthma. I can just copy this asthma and put. If I copy asthma and put, it's going to do that for me. So you can do that. Once you run.
Okay, I'm sorry, I have a question.
Okay.
Without importing the mapping and the get dummies, can you use the where method to add? Maybe you assign an additional column to the data frame and then use the where method to
Yeah, but that one, I understand what you're saying. That one is not like you just say, okay, anywhere you see female, then you are only trying to program, right?
Okay, yeah.
That one is just going to waste your time. You can use that as well. You can use that. In fact, exactly that is what we are even done here. Yeah, you don't need to even import anything. It's just mapping.
Yeah.
So that is exactly what we have done here. And that is why I even love to use mapping. You can see we have about 3, we have 2 columns. There are ways you can even do it, and you have more than 3 3 codes. So you can use that as well. And that is what we have used mapping for. So you can as well just use this and say, okay, the cells, call it this, call it this. Go and use one-hot encoding and call it, or check the head. When you check the head, you are going to get another one-hot encoding labels. So since we are using on cells, this is what we have here. I'm rushing because my time is over now. So this is what we have here. You can see the female. Female for this column is true, male is false. It's going to go and pick everything that you have. Anyway, you say female, true, this one is false, true, false, true, false, true, false. Once this one is true, the other one is going to be false. Once this one is false, the other one is going to be true. When you say true for female, it means this column is female, and male is false. You can see it's added 2 extra columns to our data frame. That is how to do one-hot encoding. So, and a lot more. So this is where we are stopping for today. Thank you for your time.
Abdul, thanks a lot for that. And sorry, everyone, we've got a bit of a short session today. Abdul's so popular, it's been double booked. So, but we will update the website with last week's session that was uploaded incorrectly. And today's session will also be up there as well in the next few days. So bear with us. Thank you for joining us, and have a wonderful weekend. We'll see you next week. Take care.
Thank you very much.
Thank you.
I would like to ask,
any questions? Sorry, any questions real quick?
Yes, we talk about, Abdul said he was going to upload the notes, the Google Colab notes we've been using so that we can use it to practice, but we've not seen it.
Oh, sorry. Can I send it to WhatsApp group?
Yes, please.
Yep.
Okay. So I will. I've downloaded it, so it's just to send. I forgot.
All right, thank you very much.
Yeah.
No problem.
Yeah.
Anybody else? Alex, Pauline? How you doing, Pauline?
Yeah, Alex, yeah. I think I'm okay.
You okay, yeah?
Yeah.
Pauline, Taiwo, anybody else?
Yeah, I'm okay. I'm all right. That's all right. Thank you very much.
No worries. Okay, guys, have a great weekend.
And you too.
See you later. Thank you.
Okay. I'm off to the other one now.
All right, buddy. Take care. Thanks, Abdul.
Yeah, thanks.